side alone at modern speeds. That risk does not make railway engineering fragile, it makes it disciplined. The answer is measured geometry, protected routes, controlled speed, verified signals, planned maintenance, and schedules with room to recover. When those habits line up, railways remind us that smooth motion is built from order. That is why the chapter on signals matters to the whole story, and why the simplest-looking moments often contain the deepest engineering. Braking. Stopping a train is a long-engineered event. Braking begins with stopping a train is a long-engineered event. A railway can look simple from far away, but up close it is a working system of materials, timing, controls, people, and trade-offs. The design has to manage track capacity, energy, time, maintenance access, station space, and public trust at the same time. That is the quiet promise behind this part of railway engineering. Make a complicated system feel ordinary enough that people can depend on it. The working pieces include air brakes, dynamic braking, regenerative braking, adhesion, wool slide protection, brake shoes, discs, and train length. Each part has to match the rest of the system. A strong component in the wrong place can still create trouble, and a small overlooked detail can ripple outward. Good design does not come from one clever part. It comes from the way the parts support each other when conditions change, when demand rises, when a component wears, or when a person has to make a decision quickly. You can see the idea in a freight train beginning to slow long before the station or curve ahead. The visible moment may be brief, but it carries the work of track engineers, signal maintainers, dispatchers, drivers, station teams, rolling stock crews, safety inspectors, and planners. They ask what must happen first, what can fail quietly, what needs a backup, what should be measured, and how someone will maintain the system after the original design team has gone home. That is where engineering becomes less like a diagram and more like a long-running promise. The risk is that a train cannot stop like a car because mass and steel rails set different rules. That risk does not make railway engineering fragile, it makes it disciplined. The answer is measured geometry.